Imagine waking up anywhere on Earth and instantly knowing where you are, how to get to your destination, and what's happening along the way. That's the power of Google Maps, a system so vast and reliable it's become the invisible backbone of modern navigation. Today, we embark on a journey to uncover how Google built the world's largest, most advanced mapping platform. From satellites orbiting above to smartphones in our pockets, every piece of technology works together to create a seamless experience for billions. Let's dive into the origins, the engineering marvels, and the hidden genius behind Google's mapping empire. For Google Maps, navigation was a patchwork of paper maps, local guides, and early digital attempts. Google saw an opportunity to digitize the world, making maps accessible, interactive, and constantly updated. The journey began with acquiring Keyhole, a company specializing in satellite imagery and digital mapping. This acquisition laid the foundation for Google Earth and soon after, Google Maps. The vision was clear: create a map so detailed and dynamic that anyone, anywhere could rely on it. The challenge? Mapping every corner of the planet from bustling cities to remote villages. Satellite imaging is the backbone of global mapping. Google leverages high-resolution satellites to capture detailed images of Earth's surface. These images are stitched together, corrected for distortions, and layered to create a base map. The process involves complex algorithms to handle cloud cover, seasonal changes, and varying resolutions. By combining multiple satellite passes, Google ensures maps are accurate and up-to-date. This technology allows us to see roads, rivers, forests, and even individual buildings from space, forming the canvas for all further mapping. GPS satellites orbit the Earth, constantly transmitting signals to receivers on the ground like your smartphone. Google Maps uses these signals to pinpoint your location with remarkable accuracy. The system relies on triangulation, where your device calculates its position based on the time it takes for signals from multiple satellites to arrive. This real-time geolocation is the foundation for navigation, route planning, and live traffic updates. Without GPS, the magic of instant directions and location sharing would be impossible. Google's iconic Street View cars are equipped with cameras, sensors, and GPS units. These vehicles drive millions of miles, capturing panoramic images and mapping road networks. The data collected is processed to create immersive street-level views, allowing users to virtually explore neighborhoods, landmarks, and businesses. Street View also helps update road layouts, identify new construction, and verify business location. It's a massive logistical operation, blending human effort with advanced technology to keep maps fresh and relevant. Artificial intelligence is at the heart of Google's mapping system. AI algorithms analyze satellite images, Street View photos, and user-submitted data to identify roads, buildings, and landmarks. Machine learning models detect changes like new roads or closed businesses and update maps automatically. AI also powers features like real-time traffic prediction, route optimization, and image recognition. By continuously learning from billions of data points, Google Maps stays accurate and responsive, adapting to the ever-changing world. Geolocation combines GPS, Wi-Fi, cellular towers, and Bluetooth signals to determine your exact position. Google Maps uses this hybrid approach to improve accuracy, especially indoors or in dense urban areas where GPS alone might struggle. Wi-Fi positioning relies on nearby networks, while cellular triangulation uses signal strength from multiple towers. This layered system ensures you're always located precisely, whether you're navigating city streets or exploring a shopping mall. Google Maps analyzes anonymized movement data from millions of smartphones to predict traffic conditions. By tracking the speed and location of devices on roads, the system identifies congestion, accidents, and road closures. This real-time analysis allows Google to update routes instantly, helping users avoid delays. Privacy is paramount. Data is anonymized and aggregated, ensuring individual users are never tracked. The result is a dynamic, responsive navigation experience that adapts to the flow of traffic. You request directions, Google Maps calculates the fastest route using sophisticated routing algorithms. These algorithms consider real-time traffic, road closures, speed limits, and historical travel patterns. The system evaluates millions of possible paths within seconds, balancing speed, safety, and convenience. By leveraging distributed computing and massive datasets, Google ensures routes are optimized for every user, whether you're driving, walking, or cycling. The result is instant, reliable navigation for billions. Google Maps relies on powerful cloud computing infrastructure to process, store, and deliver mapping data. Distributed servers across the globe handle billions of requests every day, ensuring fast response times and high reliability. Cloud computing enables real-time updates, seamless scaling, and efficient data management. By leveraging the cloud, Google can support simultaneous navigation for millions of users without crashing the system. It's the invisible engine that keeps the map running smoothly. Google's global network of data centers is the heart of its mapping system. These facilities house thousands of servers, storing petabytes of map data, satellite images, and user information. Data centers are engineered for speed, redundancy, and security, ensuring maps are always available and up-to-date. Advanced cooling, power management, and network optimization keep operations efficient. Without these data centers, the scale and reliability of Google Maps would be impossible. Cellular towers and Wi-Fi networks play a crucial role in geolocation. When GPS signals are weak or unavailable, Google Maps uses nearby cell towers and Wi-Fi hotspots to estimate your position. This technique, known as triangulation, improves accuracy in urban environments and indoors. By constantly updating databases of network locations, Google ensures maps remain precise and responsive, even in challenging conditions. Smartphones are the primary interface for Google Maps. Every device continuously communicates location data, route requests, and traffic updates to Google servers. This real-time feedback loop enables live navigation, traffic prediction, and personalized recommendations. Smartphones also contribute to crowdsourced updates, reporting new roads, closures, and business changes. Harnessing billions of devices, Google creates a living, breathing map that evolves with the world. Google Maps calculates routes almost instantly, thanks to advanced algorithms and distributed computing. When you request directions, the system analyzes current traffic, historical patterns, and road conditions. It then evaluates millions of possible routes, selecting the fastest and safest option. This process happens in the cloud, leveraging massive computational power to deliver results in seconds. The seamless experience hides the complexity, making navigation effortless for users. Google Maps supports simultaneous navigation for billions of users worldwide. This feat is achieved through distributed servers, load balancing, and real-time data synchronization. Each user's request is handled independently, ensuring fast response times and avoiding system crashes. The architecture is designed for scalability, reliability, and efficiency, making Google Maps a trusted companion for travelers, commuters, and explorers everywhere. Live traffic prediction is one of Google Maps' most impressive features. By analyzing anonymized movement data from smartphones, the system identifies congestion, accidents, and road closures in real time. Machine learning models predict traffic patterns, adjusting routes dynamically to avoid delays. This continuous feedback loop keeps navigation accurate and responsive, helping users reach their destinations faster and safer. App rendering is the process of transforming raw data into visually appealing interactive maps. Google uses advanced graphics engines to display roads, buildings, terrain, and landmarks in real time. The system adapts to zoom levels, device screens, and user preferences, ensuring maps are clear and informative. Rendering also supports features like 3D city views, satellite imagery, and custom overlays, making navigation intuitive and engaging. Offline maps allow users to navigate without an internet connection. Google Maps lets you download map regions, storing data locally on your device. The system compresses and optimizes map files, ensuring fast access and minimal storage use. Offline navigation supports route planning, turn-by-turn directions, and location search, making it invaluable for travelers and adventurers in remote areas. Google Maps features detailed 3D city models, created using satellite imagery, aerial photography, and street view data. These models enhance navigation, providing realistic views of buildings, landmarks, and terrain. 3D mapping is powered by advanced rendering engines and machine learning, allowing users to explore cities from any angle. The technology also supports augmented reality features, making navigation more immersive and intuitive. Google Maps includes millions of business listings, from restaurants to retail stores. These listings are sourced from business owners, user submissions, and public records. The system verifies information, updates hours, and displays reviews, making it easy to find and navigate to businesses. Business listings also support advertising, reservations, and delivery services, connecting users with commerce in real time. Crowdsourced updates are vital for keeping maps accurate. Users report new roads, closures, construction, and business changes directly in Google Maps. These reports are verified and integrated into the map, ensuring information stays current. Crowdsourcing leverages the collective knowledge of billions, making Google Maps a living document that evolves with the world. AI image recognition enables Google Maps to identify roads, buildings, and landmarks from satellite and street view images. Machine learning models analyze millions of photos, extracting features and updating map data automatically. This technology improves accuracy, detects changes, and supports advanced navigation features like visual search and augmented reality. Google Maps digitally maps roads, buildings, and traffic signals using satellite imagery, street view data, and crowdsourced reports. The system creates detailed vector maps, updating layouts as cities evolve. Digital mapping supports navigation, traffic analysis, and urban planning, making Google Maps an essential tool for governments, businesses, and everyday users. Behind the scenes, Google Maps relies on sophisticated engineering to deliver seamless navigation. The system uses latency optimization, distributed servers, and real-time data synchronization to ensure fast, reliable performance. Engineers constantly refine algorithms, improve infrastructure, and innovate new features. This hidden work is what makes Google Maps a trusted, indispensable tool for billions. Machine learning powers many of Google Maps' features, from traffic prediction to image recognition. Models are trained on vast datasets, learning to identify patterns, detect changes, and optimize routes. Machine learning also supports personalized recommendations, adapting maps to individual preferences and behaviors. The result is a smarter, more responsive navigation experience. GPS satellites orbit the Earth, transmitting signals to receivers on the ground. Google Maps uses these signals to calculate your location speed and direction. The system corrects for atmospheric delays, signal interference, and satellite drift, ensuring accurate navigation. GPS communication is the foundation for real-time location tracking, route planning, and traffic analysis. Google Maps and Apple Maps are the two giants of digital navigation. While both offer similar features, Google dominates with its vast data, real-time traffic analysis, and global coverage. Apple Maps focuses on privacy and integration with iOS devices but often lags in accuracy and detail. Google's advantage lies in its massive infrastructure, crowdsourced updates, and AI-powered features, making it the preferred choice for billions. Beyond Google and Apple, other navigation platforms like Here, TomTom, and Waze offer unique features. Here specializes in automotive navigation, TomTom focuses on GPS devices, and Waze leverages crowdsourced traffic reports. Each platform has strengths, but Google's scale, data quality, and AI integration set it apart as the global leader in mapping technology. Google's dominance in mapping is due to its massive infrastructure, real-time data analysis, and continuous innovation. The company invests heavily in satellite imaging, AI, cloud computing, and crowdsourcing. By integrating these technologies, Google delivers accurate, reliable, and dynamic maps for billions. Its commitment to privacy, scalability, and user experience ensures Google Maps remains the gold standard in navigation. Augmented reality, AR navigation is the next frontier for Google Maps. AR overlays directions, landmarks, and information onto the real world, using your smartphone's camera and sensors. This technology makes navigation more intuitive, helping users find their way in complex environments. Google is investing in AR features, integrating them with 3D mapping and real-time data to create immersive, interactive navigation experiences. Autonomous vehicles rely on detailed maps, real-time data, and AI-powered navigation. Google's mapping system provides the foundation for self-driving cars, enabling them to understand roads, traffic signals, and obstacles. The technology supports lane detection, route planning, and collision avoidance, making autonomous vehicles safer and more efficient. Google continues to innovate, integrating mapping with vehicle sensors and AI to drive the future of transportation. Door mapping helps users navigate complex spaces like airports, malls, and hospitals. Google Maps uses Wi-Fi positioning, Bluetooth beacons, and floor plans to create detailed indoor maps. The system supports turn-by-turn directions, location search, and accessibility features, making indoor navigation easy and inclusive. As technology advances, indoor mapping will become more precise and widespread. Real-time world scanning uses sensors, cameras, and AI to capture and update map data instantly. Google Maps integrates live feeds from Street View cars, drones, and smartphones to detect changes, update layouts, and improve accuracy. This technology ensures maps reflect the current state of the world, supporting navigation, urban planning, and emergency response. Drone mapping provides high-resolution aerial imagery, supplementing satellite and Street View data. Drones capture detailed photos of roads, buildings, and terrain, supporting 3D modeling and real-time updates. Google uses drone data to enhance map accuracy, detect changes, and support advanced navigation features. The aerial perspective is invaluable for urban planning, disaster response, and environmental monitoring. Spatial computing integrates mapping, sensors, and AI to create 3D models of the world. Google Maps uses spatial computing to support AR navigation, autonomous vehicles, and indoor mapping. The technology enables real-time interaction with digital maps, making navigation more immersive and intuitive. Spatial computing is driving the future of mapping, connecting the physical and digital worlds. AI assistants like Google Assistant integrate with Maps to provide smart navigation, personalized recommendations, and voice-guided directions. The system uses machine learning to understand user preferences, predict needs, and adapt routes. AI assistants make navigation hands-free, accessible, and intuitive, enhancing the user experience and supporting new features like AR and real-time updates. Digital Twin Earth systems create virtual models of the planet, integrating real-time data, satellite imagery, and sensor feeds. Google Maps is developing digital twins to support environmental monitoring, urban planning, and disaster response. These systems enable simulation, analysis, and visualization of global changes, making mapping more powerful and predictive. Privacy and security are central to Google Maps. The system anonymizes movement data, protects user information, and complies with global regulations. Google invests in encryption, secure servers, and privacy controls, ensuring maps are safe and trustworthy. Users can control location sharing, manage data, and opt out of tracking, balancing convenience with security. Latency optimization ensures Google Maps responds instantly to user requests. Engineers minimize delays by optimizing network routes, server performance, and data processing. The system uses distributed servers, caching, and real-time synchronization to deliver fast, reliable navigation. Latency optimization is critical for live traffic updates, route planning, and user experience. Distributed servers enable Google Maps to deliver data quickly and reliably worldwide. The system replicates map data across multiple locations, balancing load and ensuring high availability. Distributed architecture supports scalability, redundancy, and disaster recovery, making Google Maps resilient and responsive for billions of users. Google Maps updates constantly, reflecting new roads, buildings, and changes in real time. The system integrates satellite imagery, Street View data, crowdsourced reports, and business listings to keep maps accurate. Automated processes and human verification ensure updates are reliable and timely, making Google Maps a living document of the world. User experience is at the core of Google Maps. The interface is designed for simplicity, clarity, and accessibility, supporting turn-by-turn directions, real-time traffic, and personalized recommendations. Google invests in usability testing, feedback analysis, and continuous improvement, ensuring navigation is effortless and enjoyable for everyone. Google Maps has a profound global impact, supporting disaster response, urban planning, environmental monitoring, and humanitarian efforts. The system helps governments, NGOs, and communities navigate crises, plan infrastructure, and monitor changes. Google's mapping technology empowers people everywhere, making the world more connected, informed, and resilient. There are many myths about digital mapping, like the idea that maps are always perfect or that privacy is compromised. In reality, mapping is a complex, evolving process balancing accuracy, privacy, and usability. Google Maps relies on scientific methods, real-world data, and continuous innovation to deliver reliable navigation. The system is grounded in technology, not hype, making it a trustworthy guide for billions. As technology advances, Google Maps will continue to evolve, exploring new frontiers like AR navigation, autonomous vehicles, indoor mapping, and digital twin Earth systems. The future of mapping is immersive, intelligent, and predictive, connecting the physical and digital worlds. Google's commitment to innovation, accuracy, and user experience ensures that Maps will remain the world's most trusted navigation platform, guiding us through the unknown.